So in this question, we're given two polynomials. We're given f of x equals 2x cubed 6x squared plus 4x, and g of x is x squared plus 3x plus 2. So this problem is maybe a little bit tricky, but just bear with me, and I think it'll definitely make sense in the end. So the question is, which of the following polynomials, a, b, c, or d, is divisible by 2x plus 3? So let's take a moment to think about that. So if it's divisible by 2x plus 3, that means 2x plus 3 has to be a factor, right? Just like, if you have some, you're familiar with some kind of quadratic expressed as the two factors multiplied together, right? Like maybe some x plus 1 and some x, I don't know, minus 2, right? If you add these two together, you can definitely say that that h of x is divisible by x plus 1 and x minus 2, right? Because you could divide out either of those evenly and you would have like no remainder, right? So we want to know which of the choices have 2x minus 3 as a factor. So first thing we want to do is we want to see if we can factor anything out in either of these. Not factor as in, like, I know you can factor this into x plus 1 and x plus 2, but that's not what you want to do. Just, can you factor any greatest common term out of anything? G of x, no. F of x, yeah, actually, right? You can factor out our 2x. So let's do that. Let's take this down here. F of x is equal to 2x times, so now that we factored it out, this is going to be what? X squared, right? Plus 6x squared divided by 2x is going to be 3x. And plus 4x divided by 2x is just plus 2, right? And so now we have something interesting. We did that, and look at this. So we now see that this right here is identical to g of x, right? So we can actually rewrite f of x as 2x times g of x, right? You see what I'm saying? Like, this is equal to g of x, so we can just say this is f of x is 2x times g of x. Now watch. Now let's just write out our answer choices and do the following. So here we're told for a f of x, that's a terrible f, sorry about that, f of x plus g of x. Okay, so in each of these answer choices, we're just going to plug this in for f of x, and you'll see why. So this would be equal to 2x times, or we can even just say 2x g of x plus g of x. Okay, now you see the common factor that can be factored out is g of x, right? So we can convert this to g of x times 2x plus 1, right? So this is how you're going to figure out which option has 2x plus 3 as a factor. So we're saying that this combination, because of how we transformed it, this combination has 2x plus 1 as a factor, but that's not what we're interested in. So A is out. B is f of x plus 3 g of x. Okay, so if we do what we just did before, if we plug in this for f of x, we get the following. We get 2x g of x plus 3 g of x. Now, if we, just like we did up here, factor out the common g of x, we get g of x times 2x plus 3. So there it is. There's what we're looking for. The answer is B. B has a factor of 2x plus 3. And if you do this sort of procedure to C and D, I mean, I can just do it with you here real quick, you'll find that none of the rest of them actually have 2x plus 3 as a factor, right? Like C, for example, if we write this now as 2 times, right? So because it's 2 f of x, so 2 times this, so 2 times 2x g of x plus 3 g of x. Factor out our g of x, you get g of x 4x, because 2 times 2, right? 4x plus 3. So that's not what we're looking for. And for D, you would, once you get it all through, you would get g of x is, I'm sorry, not g of x times you'd get 6, I think, 6x plus 2. So I know this one's a little bit maybe, again, a little bit non-intuitive, but how you'd want to do it again is you look at these, you try to find some greatest common factor, factor it out, and usually what you'll find is that whatever's left over, you can express one function in terms of another, like this. And then from there, you plug it into each answer choice, and you see which one you can factor out to achieve the factor that you're looking for.